Okay. It is black. What happened? Okay. Okay, I don't know why it reset the whole settings. Okay, you must be wondering why am I toggling off? Because I'm going to YouTube, and YouTube has some history of what I recently watched. I don't want to let you see what I recently watched. Nothing, nothing funky lah. It's just kind of weird. Okay. Live dashboard. Okay. Right. Yes, it's going live. Nice. Okay. Okay, well, yeah, you still can kind of see what I saw. Oh. Okay, run node. Okay, cool. Let's get started. Okay, welcome. As I stated, it is a master class. Okay, so I'm actually going beyond what I try to go beyond what is covered in class. So unfortunately, this is not exactly a help class where I reiterate what has already been covered in your regular fundamentals class, but I hope to go deeper into the rationale of why we use objects and what are some of the more advanced uses of objects and classes. Okay, maybe just a quick recap, and okay, before I begin, I'd just like to have a bit of a cooperation. As I'm conducting this class, I would like your cooperation to keep quiet. Try not to interrupt my class as much as possible. Can we make that happen? Cool. Okay, so thanks to Ian. Actually, Mr. Ian Su is supposed to conduct this class, but I decided that never mind. Okay, I'll take over. Okay. Thanks to Ian. Most of the content is actually contributed by him. Okay, so agenda for today. 3 main things: what, why, and how. Okay, you probably already know what objects are. Okay, so this is the official definition provided by Mozilla. Okay, objects exist in most programming languages actually, except the very, very low level languages, not really. Okay, so long story short, which is nothing new to you, it is effectively a type of variable, but a variable that allows you to store many other variables. So some of the variables that you have already experienced up to this point of time: string, boolean, numbers, float, array objects, even functions. Okay. So why do we use objects? Okay, it is actually for the purpose of creating meaning. What do I mean by this? Okay, I use this example. Say my dog. I have a dog, a very lazy corgi. Okay, I want to store certain information about this dog. Okay, what is his name? His name is Calvi. Okay, what is the year of birth? It's an old dog, born in 2005. Okay, in dog world is old. Okay, what is his length? Okay, it's not 88.2. Okay, I just gave some random number to it. Has it been vaccinated? Okay, what are some of his puppies, etc., etc. I want to store a whole bunch of information about this dog. What you already know is that I could store a whole bunch of variables that are seemingly related but yet not related. I could declare a lot of variables to store all this information about this dog. Okay? But the reality is, when you are a programmer, assuming you're going to store information about this dog, does it make sense to create this whole bunch of variables that may or may not be related to each other? Okay? Because you know, as a human being, I know that this name, whether it's vaccinated or not, in the Boolean data, year of birth in a number, the length in a float, the find age, which is a function, and puppies is an array, I know that they all belong to my dog. So it would make sense if there is a form of mechanism that allows you to link all these variables, all properties, back to this object. Okay? So effectively, objects provide a logical clustering. What does this mean? It helps you create hierarchy structure to link back to this object. Okay? So instead of creating independent variables, I want to group properties, which are also variables, under my dog. So we use an object. So that is its primary purpose. So basically, from the my.dog example, what we have just done to use an object is to perform what we call data modeling or structuring, to create meaning, hierarchy, structure to data, instead of using variables which are totally independent or not relevant to each other. But what exactly is the other benefits, or in fact the true beauty of objects? Think about this situation. You have one dog, but the reality is you are a programmer. You don't create a program, for example, about dogs or about pets just to store your data about your dog or my dog. You want to create more data for your dog, his dog, her dog, everybody's dog. So does it mean if I want to create so much information, I have to physically declare so many variables and variables to store all these different properties, variables about everyone's different dogs? You don't want to do that. I think you probably experienced that by now. And especially, I'm going to illustrate a problem with creating independent variables without using objects. Think about this situation. All dogs have this capability or this function known as find age. So this find age logic is basically to return the date, the year, the current year, the system year that is minus year of birth, which is basically the logic or algorithm of finding the current age in years. Okay? If you do not have objects, you declare the functions pertaining to finding the age of each dog independently. You effectively have to create n functions depending on n dogs you have. You have 10 dogs, you have to create 10 separate functions. You have 100 dogs, you have to create 100 separate functions, correct? Because you have to hard code, effectively use the variable that is independent of that particular dog to put it inside the function. You have to retype this function over and over again. So that is basically what objects, or at least with the combination of object templates known as classes, to provide the reusability of code. So in this example, which you already know by now, how to declare a class, which is a template of creating objects. I basically declare a findAge function within a dog class, and whenever I create different dogs, you will be able to perform findAge in all dogs that is created using this dog class, a template. And the beauty of accessing a function that belongs to a template is the data inside is independent, yet the logic is consistent. What do I mean by this? For example, I declared a my dog which has a name Calby, vaccinated, true, year of birth 2005, length 88.2. And if I were to access the find age of this dog, what it does is the function will point back to the constructor function inside the class and perform the logic. And because of the object structure or the class structure, the year of birth is dynamically used in the class, and the year of birth, because you reference to the object, okay, it will be replaced by the year of birth that you pass it in when at creation. In technical terms, this is what we call instantiation. And let's say I have another dog. I call it your dog. Similarly, when I create Rocky, your dog is born in 2010. When I access its find age, you will be able to retrieve the current age based on the year of birth that has been passed in and return a 9 for me instead. So this function becomes dynamic and reusable so long as the conditions are different when you create this particular dog. Instead of the previous example which I've shown here, you have to create X amount of functions depending on X amount of dogs you have. Using a class, you declare once and you keep reusing them. And the output is different, yet the logic is same by reusing the same function declaration. Okay, so how do you exactly use objects in JavaScript? In your class, you are only taught, when I say class, I mean your module. Okay, in your day class, you are only taught one way, or at most 2 ways. But actually, in JavaScript, there are a few ways of using classes, or sorry, objects. This is actually the first way to use object without a proper template. You can create objects which are dynamic. You can randomly or ad hoc, impromptu create new properties into the object. So this is what we call a generic object. Okay, you create the object and you can rapidly in programs, in statements, create new properties under this object structure without a template. So this is one way, which you use square brackets to identify the property. This is effectively the same as the dot syntax way. Okay, you create an object, whether is it new object or you use the curly brace shorthand, it means the same thing. It is to create a new object called my dog, that you use my dog as a pointer to reference to this object in terms of the memory. Okay, this is the further shorthand. Okay, so instead of creating the object first and you point to the new properties, you can straight away create the properties along with the data you want to store in the properties using the curly brace shorthand. This, FYI, is also known as JavaScript object notation, in short, JSON. This will be a very important concept for you moving forward. Why? Because in the back-end development, when you are creating web services for remote access, for remote application access, you need to pass information using this format. Okay, you can get the latest information from server, from database in the form of a JSON. So you need to be familiar with this syntax or with the way that this object notation is created. Okay, and of course, this is object declaration, instantiation. You create, basically you go to the memory and you tell the memory that I want to create, park a space called my dog, and under my dog it has a name which is a string, it has a vaccinator which is a boolean, and a year of birth which is a number, but it doesn't stop you programmatically to add on new properties, be it a function, be it a string, etc. You can still add on more properties under this object. Okay, so why do we use objects specifically with classes or templates in the first place? Actually, I just want to quickly go back to why I started out, or how this class is started out. Just now I talked about reusability. Okay, objects provide reusability, but not in a very nice way. Okay, as you can see that you can randomly add on new properties, new functions, which makes the data inconsistent. What do I mean by this? Okay, let me jump straight to this example. This is using object literal without a class, without a template. In this array called dogs, I created 3 dogs and store it inside this dogs array. In each object, I have name, vaccinated, year of birth, except for the second dog, which is at index 1 of dogs array, there is an inconsistent property that belongs to this object. Is it acceptable? Yes. there won't be any error in JavaScript. This is allowed. But what is the problem with doing this? When you use a shorthand, something like a shorthand to immediately declare an object without a class, when you attempt for reusability's sake to look through all the docs, you will encounter an error here. Because in one of the docs, the property is declared as year of birth explicitly rather than YOB. Not all docs have YOB declared. So effectively, that is what I'm trying to drive at. Why do we use classes or a template? Imagine with a doc class. What a doc class basically does for you as a programmer is it gives you a certain consistent structure. When you create a new doc, you don't care what the property is. You only pass in the value to the predefined properties. You can be sure that the new doc or my doc using the doc structure that is instantiated in the memory is certain to have name, vaccinated, YOB, and the find age function. Okay? So effectively, coming back to the same example, if I were to create a series of 3 docs and store them in the docs array again, this will no longer have a problem. You can be quite certain that there won't be a problem because all docs created using the class doc structure template will have YOB. Okay? FYI, this is the second way in JavaScript that you create a class. This is probably something that wasn't covered in class. In FOP, you were taught the class way, but actually traditionally, objects, functions, variables, they are usually created using the function way. This is effectively the same as using the class. FYI only. Whether you use the class or whether you use the function way, they are all the same. The function will return you with a dot class. The class instantiated will return you with a dot class. Same. So, I want to go into something deeper. Why do you really use class? There is this concept in computer science and programming known as scalability, inheritance, polymorphism. What is this? Scalability, also known as extensibility, is something that all programmers should strive to achieve. Why? Because a good program is able to change without being modified. Wow, what is this? How do I change it without modifying it? OMG. Okay. I'm going to introduce a new way of using class. I'm not sure how many of you actually do this or how many of your lecturer actually covers this function. Can I have a show of hands? Who was being taught extents? Other than my class, anyone? Were you all taught this keyword class name extends the parent class? No. Okay, exactly. This is why we have an enrichment program like this. I want to cover more things. Okay? I want to teach you something new. Okay, imagine this situation. Think about this. I already have a doc class, which stores the 3 properties, name, vaccinated, year of birth, and it has a find age function. But let's say one day, I want to make my program even better. I want to add a new functionality to it, which always happen. As a software engineer, right, change is the only constant. Because as a software programmer, your clients are clueless. Your clients, your users will always come to you, I want this, but when you actually created it, they don't know what they want. So as a programmer, expect change. Think about this situation. Now, maybe in a database, in some pets database, in some game application or whatever, your client come to you and tell you that I want to add a new feature to this dog. My dog now is able to become a super dog for some reason. Maybe they ate the wrong dog food. They become a super dog, okay? Or they were exposed to some radiation. You decided that you want to store them as a super dog. And the way age is calculated for super dogs is logically different, is algorithmically different. So the algorithm here is, if you find the age of a super dog, it has only half the age of a normal dog. Let's say this year is 2019. If this dog is born in 2010, it only has an age of 4.5, half of a normal dog. Okay, I know that's not even logical, but just assume that it is possible and your client demands that. Like I said, your clients are idiots, usually. So they will demand the most ridiculous things from you. You just got to do it, like it or not. So instead of changing the dog, what I'm going to do is, I'm going to extend the usual dog and what we call method overriding, use the original method and change the logic of the new method for a super dog. Both dog and super dogs have find age, but the way they perform finding age is different. What is the purpose of doing this? The purpose of doing this is so that when you have an old program that still uses dog class, it doesn't fail. You have a new program that both uses super dog and dogs, you are given two sets of functionality. Okay? So this is the extends syntax. Okay, of course I have more examples, like for instance, in the school database, you have teachers, you have students, they both share similar properties. For example, name, gender, date of birth, consistent properties. Whereas for a teacher, you keep track of the subject, you keep track of the year this teacher is teaching. Whereas for students, you don't keep track of the subjects these students teach. They don't teach anything. All you keep track is grades, for example. Okay? And the consistent data about them is, say for example, a person. For code reusability perspective, I can create a person which has consistent data about both of them. And what I do here is I create different extended classes, okay, to extend from this person so that I don't have to recode whatever I have coded in a person class or in a person object. I can reuse whatever properties or functionalities, algorithms, capabilities, map it over to teacher class and add on new capabilities. Okay, so that is the explanation in a nutshell. Now I want you to experience building and using classes and extended classes on your own. I want you to experience what is exactly the pain or beauty of using extensions. So all of you have been sent a link where you can download the materials. I want you to open up your email that you have been sent with the link, go to that Google Drive, download the two files. Okay, you should have these two files. I would strongly encourage you to follow along. Okay, I believe all of you should have Visual Studio Code as your IDE, integrated / independent developer environment. I want you to start. Okay, I'm actually quite curious. Someone said it's black. Yeah, it is black. Okay. Okay, so what I want you to do is create a fresh folder. Okay, put these two files into that fresh folder. Okay, in my case, I'm going to call it WIP. It means work in progress. So I want you to copy these two files and put it into a folder. Okay, so this is a bit of an appreciation class where I'm going to use JavaScript integrated into HTML and CSS as a game. Okay, so it's going to take your understanding, it's going to push your understanding a bit, but it's called a MasterClass. Okay, like I said, this is not a revision class. Okay, you can open it up and try it, and you will see something like this. Okay, it is a very simple game where you have to dodge the falling black boxes. Okay, so every box that you avoid, you get a score. The score will be appended onto the yellow box, which is the main character, the protagonist. Okay, the moment you hit one of these enemy, you will die, complete the game, and the game will end. Okay, so that is the intention of this game. Okay, helpers, can help me go and look around to see if anyone needs help. Yeah. Okay, so once you have them in a folder, I presume all of you have Visual Studio Code. What you need to do is you simply have to add a folder to point to the WIP. In my case, it's a WIP folder. I'm going to add a folder to the workspace. Okay. So I'm going to point to my WIP folder, which I have the enemy class and the game running logic. Okay, it's a very simple game. Please don't give me the feedback saying that your game is too simple. Okay, I'll be hurt. No, just kidding. Okay, anyone has any issue opening up the files? Downloading the file? Any issue? Very good, thank you. Thank you for the feedback. Okay, so I will just quickly run through, programmatically explain what is inside this game and how is it created. Okay, so let us first visit the class called enemy, which are all these little black boxes that come down. Every time a new enemy, right, it will create this black box that you're trying to avoid. Okay, so I believe you already know what is a constructor. So in my constructor logic, it has quite a number of things. I can pass in the speed, at what rate it is moving down, what size is this enemy. Effectively, that means I can create different enemies of different sizes, what color it is, and what position is it starting with. As you can see that the enemies are starting from different positions. Actually, right now I'm doing it as a random position across the width of the browser. Okay, so this is a bit of a HTML window DOM JavaScript. Okay, like I said, sorry, this is not a fundamental class. I will not go into the basics of explaining what a DOM is. I believe you already know what a DOM is. A DOM is a predefined global object given to you by the window, allowing you to access or manipulate the elements on the HTML text as the HTML tag. Okay? So whenever I create an enemy, I instantiate an enemy, what I'm trying to do here is I create an element, a div tag, onto my HTML. So that is why you see the black boxes appearing. It is effectively a div element, and I will add it to the body of the HTML. And I will set the size, the height and width of this DOM to be the size that is being passed into this constructor. When I new enemy, I set the size, that is how big it will look. Okay? Okay. And if I create this enemy without a position, it will default the position to start on the left corner. That is this logic. And how does it move? Basically, what I did here was I create a variable to store an interval function. Okay, you might not have learned this. This is basically a timer in HTML. Okay, so the interval allows you to do certain things, perform certain functions at a certain interval. So it takes in two arguments, what you want to do at each interval and at what frequency is happening. The number here is milliseconds. So at every 10 milliseconds, okay, I will move this enemy div by 10. Okay, by the speed that I pass in as the constructor. If the constructor I pass in, okay, is 50, every 10 milliseconds it will move 50 pixels, for example, downwards. Okay. I also give it a function where you can set the position of its left to right. Okay, on the X position. Okay, in this object or in this class, I also have this function called move. I can effectively move this object, this div around the HTML by using a move function. Okay, but actually I didn't use this function at all because I wanted to use this object in my other project as well. So I kind of put in this function. Okay, ignore it. It's not relevant. Okay, and I also have a destroy function. So this destroy function later will be used to kill this, what we call in gaming terms, sprite or asset. Okay, when it hits, for example, the character, I want to destroy it, or when it reaches the end of the HTML, I want to destroy it. Why? Why do you want to destroy it? Because if you don't destroy it, right, yes, it will be out of the screen, but actually it's still in the memory. I'm sure maybe 10 minutes later, right, your HTML, your browser will lag like don't know what if you don't destroy it. Okay? But actually the problem with JavaScript is it doesn't really destroy it in memory. It's just waiting for this thing or what we call as garbage collection later when it's not used to go and remove it. In JavaScript, you can't really actually go to memory and destroy it, unfortunately. Okay? Good and bad. So that is the enemy logic. So in the actual game logic itself, I give some logic, or I basically decided how the main character will look like. So in the HTML, you will see that there is this div called main character. In it, it stores nothing. How it looks, how it behaves is purely manipulated by my game logic in the script tag itself. What I'm doing here is I wait for the entire DOM to be loaded so I can look for the main character div. I set the background color to yellow, set the hard-coded its size to be 50, set the border around it, set the position to be absolute so that it takes the position XY in reference to the HTML client screen. Okay. I want to set the default position, the starting position, to be the center of the screen. So I take the window.innerWidth, divide by 2, and adjust it a bit. Okay. So this is the movement logic. Whenever you press a key down on the window, you can move it to the left or move it to the right. And it has some very basic validation logic. If it has reached the end of the screen, you should not move it anymore. For example, when I've actually reached the end of the screen, it will not move anymore. When I reach, for example, the other end of the screen, it will not be able to move anymore. You don't want your main character to move out of the window. Okay? Okay. So I have another function here. Okay, so this is a very, very simple rectangle-based, what we call collision detection algorithm. So what it does is you take the X, Y, and height and width position of the enemy you want to test against the other object that you want to collide. And when it collides in terms of intersection of certain XY pixels, you will return a certain action. In my case, this function returns a true or false. So I call this function a heat test. Okay, I also created functions where I instantiate the enemy. Okay, so you will see that this is where I use my enemy class. And I will repeatedly use them in the actual game logic. So in the game logic, when I'm running the game, I will set an interval to repeatedly create enemy in which I will create new objects that are falling down at every 2 seconds. 1000 milliseconds is equals to 1 second. So 2000 milliseconds is 2 seconds. So at the rate of every 2 seconds, this enemy will be created. Okay? So, and at every interval, okay, is like the game frame. Okay, at every frame, what I will do is I will check whether the enemy or the enemy boxes have reached the end of the screen. If it has reached the end of the screen, they will do a few things. I will add 1 to the score. I will destroy the enemy. I will remove the enemies from the array of enemies that I'm creating. Okay? So remember, not key to you. You might never go into building a game. Whenever you are building a game like this, a web game, for example, you need to keep track of where your enemies are. Even if they are out of the screen, it's good to know where they are. So what I'm actually doing here is I use an array to store all my enemies. So later I can remove all of them from memory, for example. So every time I create an enemy, I'm pushing this new object into the array. Okay, and for such removal of objects or enemies, you need to do a reverse loop. You will see that my loop starts from the maximum number of enemies to move it down to do check on every hit test. Why? Conceptually, if you have 3 objects, if your array moves, your loop moves from in an incremental way. If let's say when I hit the second object, I remove this second object, your third object will become second object, right? And what is the next move? You move to the next object, right? This object becomes null. You will hit an error. So if you have a destruction kind of logic, you need to move it down. So when you at any point of time remove the object, you are moving to the next one without hitting a null pointer. Okay? Some very basic gaming concept. Okay, anyway, so if at any point of time your main character hits all of the enemies, you are dead. That's the basic logic. So now is the part where you have to get your hands a bit dirty. I want to show you what you are moving into. So basically, this is the part that I did not provide for you. In a new version of the game, I have basic consistent functionality, but suddenly you have this new boss appearing. So this is my new version of the game. Okay, every time I avoid a boss, you will receive a congratulatory note, boss avoided. Okay, and it moves faster than the rest. Okay, so on and so forth. Same thing, the same logic applies. When you hit any one of them, you will die, and you move on. Okay, so how do we do this? Okay, we can do the very traditional way. Okay, and knowing that we created classes for the sake of reusability. We want to reuse whatever existing code we have as much as possible. So the first approach is we can go back and change the enemy class. How do we do that? Okay. So what I want you to do is in that folder that you have, okay, open up the enemy class. This is the approach that I mentioned earlier, which is not the ideal approach. Keep that in mind. This is changing the actual codes, but not extending it, which is not a good way. Okay, but I will show you how it can be done. So let's say I know that I'm creating potentially a new type of enemy, but it is still an enemy. Without extending the class, okay, I could change some of the behavior by, for example, specifying a new property. So in the constructor class, I want you to add in a new property or a new argument called boss. So basically what boss takes in is a true and false Boolean argument. Okay. So I know that the regular enemy is declared taking its explicit exact speed and assign it to the enemy speed. But if I know that boss is equals to true, I want to change the speed and the size. So what I'm going to do here is I'm going to assign or issue a if else statement. If boss equals to true, or just boss, knowing that boss is boolean, I don't even actually have to compare against true. But for simplicity's sake, I'm going to wrap this around in an if condition. If boss equals to true, okay, as a good programming practice, always indent your codes. If boss equals to true, the speed that is being passed in will be multiplied by 2. Okay? And I am going to override the color. Not this, don't need this dot color. I'm just going to straight away take the color that is passed in and force it into red. Okay? Next, what if boss is false? That means I just want to create a normal boss, a normal enemy, using the same object. Else if boss equals to false, or exclamation mark boss, what do? Maintain the same logic. Speed equals to speed, not spend. Sorry, I've been thinking too much about money. This dot size equals to size. Okay? Period. That's all. That's all it takes. Seriously. Okay? What you need to change now is your actual game HTML logic. I'll come to that later. Okay? Everyone following? So far so good? Great. Okay. Make sure you got this right. So now, coming to the game.html, don't touch anything yet. Even before touching anything, remember this is a new game with a new functionality. Save this game.html into game v2.html. So I'm going to file, save as, game v2. Okay. Okay, actually any other name other than overriding your original game lah. Okay. Good. Okay. After you have saved a new file, what you need to do is, okay, go to line number 44. Go to line number 44. Okay. Now remember, your constructor is different. You can no longer create a new enemy with 4 arguments. You need the 5th argument now, which is a true or false. So according to my constructor template, my 5th argument takes in a true or false. So if I want to create a regular enemy, I have to pass in a false, which keeps the normal enemy, which keeps a normal enemy normal. Okay. As simple as that. Okay, now I want you to copy this function. copy this create enemy function from line 41 to 45, copy, create some space between the function create enemy and function run game, and paste it in. So I got two create enemy functions now. I want to change the create enemy function to create boss. Oh, sounds daunting. Boss. And very simply, changing the false to true. Okay. All follow. All follow? Good. I have a logic at line, okay, right now it's 56 lah. But you go and look for the third line after the start of the run game function. Okay, you look for this particular declaration. Same thing, copy this line, duplicate it, and instead of create enemy, I say create boss. Okay, so like I said, create enemy, change it to create boss, and change the function to create boss and update it to every 10 seconds. Okay, every 10 seconds. Okay, last step. Okay, now we got to make sure that when the game has ended, you clear the interval as well. So at about line 68, after the else if statement for hit test, clear interval game dot create boss. Okay, so once you have done this, try running your game v2 and see whether the boss appears or not. Okay. Okay. Does it work? Anyone running into any bug? All good? Okay. Now, I want you to go back to the original game.html and run it and see if it's still running. Whose is still running? Still running. Does it work? Does your enemy appear? Yeah, it still appears. Got refresh or not? You got refresh or not? It works. Help me check. Let's see. Still appears. Oh, no. Wait. Can I take a look? Oh, else if. Sorry. Okay. Okay. Sorry. The correct. Okay, make sure this is correct. It is else if, not else. You want to check specifically that boss is false. If you just put an else, right, it might work. Okay, but we want to take in a very specific parameter because why? Next time in future, there could be boss, bigger boss, super boss, etc. Doesn't matter. Okay, make sure you go back to the enemy class. You perform this. This is the actual code. Sorry. Still works. Sorry. This is V2. Does your original work? Doesn't work really. Okay. Okay. After changing it, whose codes still work? Okay. Okay, can I just have your attention for now? Okay, just look up to the front. Basically, we have gone through a whole exercise to do the wrong thing. Why? Okay, I will tell you, this is the reality that you will face in the industry. What do I mean by this? You create multiple versions of the game and you change the logic to the previous version, thinking that you want to adapt to the newer version. But you fail to understand that because of reusability concept, both your games are still using the same enemy class. You fail to understand that there is what we call coupling. Coupling means that you still use the same old code, but for a new function in another version. So how do we avoid this problem? This is exactly what class is meant for, extension. I can effectively not touch the same enemy.js and extend a new boss.js and create a new version of the game without breaking the old game. Okay? So what I want you to do now is rename the enemy.js and add a .bak at the back. Okay, this is a common practice. If we no longer want to use this code, we just add a .bak. I mean, it can be anything, any file extension that is no longer recognizable by the computer. It means backup. Okay, and sometimes we'll put a .bak with a timestamp back to it. So we know when was this file being deprecated or not used anymore. Okay, so I'm going to use it, I'm going to rename it as js.bak so that my game files can no longer reference to it. It can no longer be used. Okay, so once this is done, I want you to go to that link where you downloaded the enemy.js and download it and put it into that folder again. I should have asked you to not touch the copy and keep a copy, right? Okay, yeah, I know. On the high side, it's okay. So I'm going to use the original enemy.js and put it into my working folder again. Okay, all done, all reverted. The technical programming term is called rollback. You roll back from a certain change, which always happen. When you go and support a real system in the industry, you do already got bug, then you roll back. What are you being paid for? You are being paid as a programmer to roll back on your own codes. Sometimes you even have to roll back on your colleagues' codes, which you don't even know what it does. Always happen. So long as it doesn't break. Something works, but you don't know what works. Okay, anyway. Sorry, programmer joke, which you cannot understand. Okay, now, I'm going to create a new class without touching my enemy.js now. So I have rolled back to the version which I first downloaded meant for my first game version. Okay, now I want to create a new file in the same folder called boss.js. Boss. Okay. Retype whatever that is in enemy. No, just kidding. Just kidding. Just kidding. Okay. Okay. Class boss extends enemy. Okay. What comes after class? What is the most next default function? Very good. Constructor takes in the same arguments, speed, size, color, and position without changing anything. Okay. Instead of rewriting whatever the enemy has in constructor, I'm going to reuse it. How do I do that? Very simply. Very good. Super. What this means is I make use of my super class, which is enemy, and take whatever I've coded in its constructor to repeat it into the boss constructor. But that's not all. Of course, I need to pass in the same speed, size, color, and position. Speed, size, color, and position. Okay. But boss has a different capability, right? Sorry. When I create a boss, I don't want to create a normal enemy. When I create a boss, I can alter the logic. The speed is times 2. The size is times 2. and I don't want the color to be any color. I want it die to be red. No matter what the user passes in, I will override it to be red. Okay. That's all. Okay. So now let's go back to okay. Sorry, who needs more time? Make sure you copy correctly. Anyone still copying? Still copying. Okay, good. Once you're done, let me know. Okay. Done. Okay, good. Okay, so now we go back to our game V2, which is not a very good way of coding, like I earlier mentioned. So now I know that the enemy.js has been reverted back to the original enemy.js, which is nothing special. I am going to import boss now. And boss needs enemy to work. Please don't go and put boss before enemy. You need to create your enemy first before you can create a boss. Okay. Okay. Anyone still doing? Still doing? Okay, good. So now, no worries. Go back to line 45 onwards. In your game V2, we no longer have the force, right? Remove it away. Let's roll back. Same thing for create boss. Let's roll back. Okay. But in your create boss function, we need to change something. It's no longer enemy. It is a specific class called boss. Okay. So key change, number one, remove the last true or false. Remove the last true or false. Change enemy to boss. Change the new enemy to boss. Okay. You can now try and see whether game V2 works as per normal or not. And after your game V2 works as per normal, you go back and try your original game. Does it still work as per normal? Okay. Anyone? Any problem? Running into any problem? So now, your both original game and game V2 works as per normal. Anyone? Any problem? Facing any problem? Boss doesn't appear. boss is not defined. Never include the script boss. Okay. You want to use boss, you need to put him in, just like your require. Okay. Okay? Okay. Can? All good? Okay. That's not all. That's not all. Classes are more powerful than that. It's not just about construction. It's not just about instantiation. I can even override a function. So I want you to go to boss.js. Okay. All enemy classes or all enemy class. What all am I talking about? There's only one enemy class. Okay. The enemy class has a function called destroy. Correct? Destroy was an original function provided in the enemy class. But I want to change the way a boss dies. Okay? I want it to do something special, which is when it got destroyed, I want to alert boss died, for example. Okay? But I still want the normal destroy function. How do I do that? Do I have to recode whatever that was in the original destroy? No. Same thing, we use super.destroy. Super refers to the extended class function. So I have added new capability. Okay, pardon my poor spelling. To the boss class, and I retained its original functionality. In software engineering, this is called regression compatibility. I'm able to move backwards to reuse its original function. My test cases will still work. Now I want you to try the game V2 again with the boss and see whether a new function appears or not. See whether when the boss dies, successfully evaded, do you get a congratulatory note telling you that the boss has died? All good? Who is on the webinar? Anyone? I'm curious whether the streaming is still streaming. Oh, it is. Okay, cool. Your boss not appearing. Okay, let's see. Where's your HTML? Oh. Maximum cost. Oh. Oh no. New boss, not create boss. Huh? Where infinite loop? Okay. Your alert as well. welcome. I didn't do anything. Okay. We are coming to an end. Okay. Yeah, it's a small workshop, mini workshop, not the full class. Okay, shh, listen up. Can I have your attention, please? Okay, so basically, shh, sorry, I need your cooperation. If not, we cannot go home. Or at least I cannot go home. Maybe you all don't want to go home. Okay. Basically, shh, hey guys. Hello. I know Samuel is a GD top student. He's showing something very interesting right now. Okay, guys. So basically, I have shown you a real software engineering problem, which is I'm creating multiple versions of my applications, but how do I manage to reuse the codes and extending its capabilities without changing the original code so that my older versions can always still be used? This effectively what we have done a few things. Polymorphism, taking the original data structure, changing it to meet our new needs, inheriting the reusable properties for the purpose of extensibility and scalability, using extension classes. Okay, this is what JavaScript recent years provided for you from ECMAScript version 6 onwards. But this is a very common concept in other programming languages. Just that in JavaScript, it was actually never really meant as what we call an object-oriented programming language. But in recent years, such syntax sugar stuff appears. That's why you have such capability. Okay? So we have come to an end. I hope you enjoyed this mini masterclass. Before you go off, I will first end my streaming first before I stop.